I'm going to present our CANSAT preliminary design review. This in representation of my team, which is the team number 3, and our name is the Miners of Zacatecas. This one in honor of the Mexico Second Division football soccer team. It is important to mention that we are not associated with the team, and they are not given any sponsor about this. So let's get started. But just before we start, I want to give the thanks to my professor Eloy Marquez and the Autonomous University of Chihuahua for making this possible. Since I was a kid, one of my dreams was to put my feet on a scenario like this and present an aerospace project. So thanks to the CANSAT organization for giving us the opportunity to be here and to share our project with you. So let's get started in the presentation. So the outline of the presentation to come is this one. First, I'm going to mention all the members of the team and their abilities and contribution to the project, and the way of the organization inside this team, which in my opinion is one of the keys to achieve the project and finish in an efficient daily. Then I'm going to explain the application of Microsoft Access in a structured database of requirements that give us the vision of the classification and system level requirements. In third step, we have the system level concept configuration, traits, and selection with the CANSAT system configuration chart, preliminary system level concept considered, criteria for final configuration and selection, and finally the CANAPS, obviously one of the most important steps in this project, and the CANSAT budget and other costs. This cost is unestimated, and we are going to check it. Finally, the program schedule review. This last one is another way to structure the work inside the team and put over the table a perfect timing for any process during the life cycle of the system. Here we have a table with all the members of the team, which start with Juan Martin Macias, and his special skills and knowledge are basic systems control. He's very good in systems control, programming, trade studies. Then we have Javier Arellano, which is an expert in programming because he's in the robotic club of the university. Then we have Fernando Daniel, and he is very good in materials because he takes his social service in the CIMAP. Then we have Edgar Leon, which is myself, and I don't agree with all these skills, but the CFD is one of my favorites because I take a various course in ANSYS and other softwares, and I'm good in that. Then we have OMAR HERNANDEZ, which is very good in the sensors and the automations. He's an expert in Arduino and these things of robotics, and he helped out with this in the team. So here we have a very basic diagram of the organization of the team, with all the members distributed in specific areas of the project. First we have our faculty advisor, Eloy Marquez, which is very clear with his change and what he likes and don't likes about the project in every step, so thanks for him. All the other teams is distributed in the 3 concepts that we generated in the project. So the passive braking system, led by Javier Arellano, the rigid aerofoils with Juan Macias, and the force sensor with Fernando Jaquez. So if you look this, we don't have an expertise in these topics, so we mix all the members and in areas that her dominance is not too good, but it's a very interesting because everyone is helping and sharing information about the system, so it's very interesting this one. Here we have the systems overview. So before to start to explain the system overview, I'm going to explain the way that we classify all the requirements in his level, and the way that we take the advantage of Microsoft Access in the database systems. So the first one is to establish all the requirements in a table and a database table. So let's check this one in the next slides. Firstly, we take the requirements database classification. So we take two principal classification for this. Obviously the system level, that is functional, performance, constraint, reliability, safety, interface, environmental requirement. In this one we put a number for any type of classification. In the right side we have the other classification that we use, that is the consideration value, that is vital, secondary, optional. This means that the requirements that are vital would have the number one in her classification. If is a requirement that is not too necessary, that is optional, so we put at number 3 in the classification. So this is the first two tables to our database, and let's check the next one. So the last two tables on our database in Microsoft Access is the elaboration order, which don't need any explain in this table, so it's just that. The number one the first order, the second, and the third. Don't care about it. And the right side table is the table of all requirements in this version of the CANSAT, with the ID requirement number with the specific ID of the official document of the requirements in the page of CANSAT. So this relation gives us a very exclusive way to put this database together. So let's see the relations between them, and then look after the relation over the requirements and the order to make it. Finally, we have the relation between all the tables showed before. If you have any relation with the software of Microsoft Access, you know that any table needs a relation to make the database structure and a format to see all the requirements together and all the configuration to these requirements. So in this case, we put 4 classifications to the requirements, and the center table is only a form to elaborate the requirements classification. So as you see here, we have infinite numbers of ID to this table, but only one in the type of requirements level of value elaboration order. So this means we don't have we will don't have any requirement with the same configuration code. So let's see the classification table to understand this in a better way. Finally, we have the form of the table of our database. So as we can see, we have the 4 configurations of, in the better way, the 4 classification of the requirements: the ID type, the ID value, the ID elaboration order, and finally the ID requirement. So it's important to mention that if you don't know the classification order and the specific number, you will have an incorrect understanding of these requirements. So as we see in the previous tables, we have any specific number for any type of requirement. So this means the number 1 means performance, the number 2 means safety, etc., etc. So as we can see, we have we don't have any repeated requirement in this table. We have 1, 1, 25, 1, 1, 1, 1, 2, 26, and we don't have any repeated in this code. So it's a better way to understand these requirements and to classify it in the correct order. So let's see the final table in the next slide. So here we have the final table of the Microsoft Access Requirements database. As we can see, the contribution or the punch in this criteria is that we have the ID and the meaning of that ID. So as we can see in the first one, we have 1125, which means a functional, vital, and first order requirement, and finally the description of that requirement. In the second one, we have 11226, functional, vital, and second order, and the other requirements are classified in the same way. The big advantage here is that we can see all the requirements and the order of that requirements at the system level of these requirements. So we can see functional, performance, vital, secondary, optional requirements in different weights and mixing all together, but with the classification in one click. So with this table took a lot of time, so is one of the best advantage of the project. So in the next slides, we are going to check the system level CANSAT configuration trait and the selection of this configuration. So in my opinion, this section is the most important of the presentation, and the steps to make this selection were one of the most challenging decisions of my life as a student, and I'm not overrated this. To select a configuration for this competition was a full stress moment for the team, just because it's our first competition at this level. So we only put 3 alternatives to the variation of concepts, and it was a big limit for us to vary the combination and put over the table different concepts. So I talked too much in this slide. Let's move to the real game. As we see here, there are 3 principal axes to move our concept and design: the passive braking system, the control, and finally the secure sensor section. In the first one, we have 4 alternatives for the design: the streamer, the round parachute, and parachute. The advantages and problems with any of them are divided into sections: stability and weight. So we need to give priority to one of them to select as a concept. Then we have the control: rigid and semi-rigid airfoils, in which the critical parameter is how much easy it is to manufacture this type of airfoils. And finally, we have the sensor method with 2 different choices: camera and sensor for the force of impact. In this case, the cost or how much expensive is one of them is the key to select one or another one. So let's move on the next one. Here we can see the preliminary system level concept considered. So with this limit of only 3 axes for the design, we can make 8 different architectures mixing all the possibilities of the design. This number will consider 2 less than other possible alternatives, but in the start of the project we decided that it will be better to have few architectures to evaluate any of them, because if we put too much architecture or timing testing and evaluate will reduce and change all the subsequent steps. You know what I mean? So our final 2 architectures was the number 1 and the number 8, just because the priority criteria mentioned in the previous slide. So let's see the priority criteria in the next one, and look why we select these 2 architecture for the design. The priority criteria that we use in the next one is the components and space local availability, just because, as you know, we are from Mexico, specifically from Chihuahua, and even that we are an aerospace city, these aerospace technologies and manufacturing are only for the industrial sector, you know, and the material and process are too expensive for the academic area. Because efficient parts, this criteria is related with the previous one. If we don't have the opportunity of a sponsor, the cost of the CANSAT will be too high, and for obvious reasons, bring to us materials for other areas will increment the cost of the CANSAT, obviously. Finally, we have standardized and optimizing computer usage. This means software and facilities, but it's not too problematic with other in comparison with the other criteria, because in the university we have workstation and laboratories to make this possible. So let's move in the next one. The selected configuration after analysis was this one firstly run parachute because give us major control weight relation in comparison to other passive braking systems. In the control, a rigid airfoil are the better option for the disponibility of materials on Chihuahua and the machining process to make them. We don't have any CNC on the university, CNC machine. So the Senaltec, which is a center of technology and capacitation, will give us the opportunity to make the process in these machines. So finally, the sensor is selected just because it's too much cheaper than any option. A camera will be very expensive, maybe too expensive is that. We have the better option in the sensor. Okay, our overview of CANSAT CANOP is the next. Pre-launch preparation activities, launch with the starting the system and start analyzing that provide telemetry. Ascent and rocket separation, science payload is deployed, parachute deploying, and recovery of PFR. So in the next slide, we are going to check the image of the canops to see the real canops in more specific way. Okay, so here is a general view of the canops. So it's important to mention that it's a general review of all the state of the operations. So it's not a final representation, but it's a better way to visualize all the canops in the real project. So take that into account. So okay, in this section we will explain the cost of some important components of the CANSAT. The cost is obviously in dollars, but it's important to mention that some components was purchased in Mexico. So the conversion is on the price of October 2020, which is about 20 pesos mexicanos, some like this. So take that in account to the real cost of the CANSAT. Okay, in this slide we can see the table of all the components and the price of them, the cost of them, excuse me. The cost of all the hardware components is in this table. Some of them have a range of price, of cost. One of the expensive components in the CANSAT is the computer devices, just because all the electronics need a special requirement for the safety requirement. And same thing occurs with the 3D printed airfoil. So even that is it is a 3D printer in our university, the cost of the material are not on our favor, but the decision to a 3D printing design give us the opportunity of save a lot of time and save a lot of money as well. So it's a win-to-win decision. Okay, this is another part of the previous table. I mean, in the previous slide, this is another one. So finally, we can see that the ground station is the other thing to take care about it respect to the cost, because the installation have an extra cost and need to be taken into account. And another cost for the CANSAT competition range from $220 to $420. So it's the range of the price of other things. The rentals on travel don't generate costs at this year specifically because of the pandemic situation. So we'll have a virtual demonstration like this video, and it's not a problem. All the other costs adding to this travel. And anyways, okay, if you are bored or tired of hearing me, you are good because it's the last slide. To finish this presentation, there is our program schedule overview, which is separated in 4 phases. Administration is the first one, where here we establish the team and talk with all our ideas and skills for the projects and analyze all the previous competitions and some art studio. Then we establish the mechanics and aerodynamics phase, which is the phase 2. In this phase, we put a focus on the design, and the principal goal is to make a real prototype to test at the final of the phase. And the third phase is the test and improvement, which is here the principal goal is to make the necessary correction at an early time and not in the phase 4. So it's very important to make the correction in the perfect time to don't care about it. And the final phase is the preparation for the competition, which is all the documentations and all other things to participate in this competition. You know that you are not an engineer if you don't do the documentation. You are not making system engineering without this documentation, so it's very important, the last phase of the schedule. And so this is the finished slide of the presentation. I wanna give the thanks to all the members, teams, and the faculty advisor Eloy Market to give us the opportunity to be here and to share this project with you. And that's it. It's a dream come true to be here and talk with you about this project. Thank you to the team, and thank you to the faculty advisor. Goodbye. See you in the next one.